Good morning. My name is Kelly Davila. I'm a senior research analyst at the Polis Center at IUPUI. My academic background is in anthropology and urban planning, and my research interest is in the way that people both build the world around them and interact with that world that they've built. So spatial statistics is kind of a fancy sounding way to do statistics about location. I think it's more familiar to you than it may seem at first. But I'll start with statistics as we tend to think about them just in terms of data. As we tend to think about it, statistics is the study of independent and dependent variables. So for example, in this image, the plant's growth is dependent upon the temperature that it's exposed to. So we can look at those two variables kind of in a vacuum and see like what temperature, how does temperature affect growth, and then how does that compare to just random chance. But we know that when we're dealing with space and spatial location, that the location itself also has an influence on the way that something is perceived or something is measured. So in this example, we know that homes on the beach are not just the cost of the materials and the land, the location factors in also to that cost. So in order to overcome the limitation of this inability to measure physical locations, sometimes with just regular data, we needed to kind of A, update the math, and B, create software and technology that kind of helps us look at these patterns spatially. So that's why we now have this field. It's a little bit of an emerging field called spatial statistics. It's also sometimes called spatial analysis that relies on geographical data alongside measurable independent and dependent variables. So again, also called spatial analysis, it helps us draw conclusions from the observed world around us using both physical location and different features about the observed thing that we're looking at. So I think this is a pretty familiar model to many of you. This is just precipitation. So looking at this, we can see that there's a product of nearness, for lack of a better word. So the closer things are together, the more similar they tend to be. We can see that in the mountains and the desert, there's less precipitation. That's you can confirm your idea that there might be some physical factors that influence some variable. Whereas in the Gulf region, you see more precipitation that I think is kind of confirmed by common sense. So what we're doing in spatial statistics is including something called a proximity effect. And again, that's just the impact of a nearness factor on an observed phenomenon. So in this example, this is 3 different ways of visualizing the same set of data in this county. The first image on the left is using a quantile distribution, so breaking up into 5 separate but equal buckets. In the middle is an equal interval. It's a different kind of way of slicing up the data, but on the far right is a statistical model looking at the nearness effect of this variable, which I think is like population over 65, where you can see there's a definite hot spot in the north and a definite cold spot in kind of the southeast region. And again, sometimes common sense can help confirm these suspicions. And I think one good example of that might be that the economies of Indianapolis and Carmel are probably pretty similar, but the economies of Indianapolis and like Miami Beach are probably not. There's a lot of factors that go into that, but some of it does come from the location of the place and the location of the features that we're measuring. So in order to do this, we use some piece of technology called a geographic information system, which is just a software suite that includes mathematics in mapping and cartography generally. So it allows us to build that proximity effect into the things that we're looking at. So in this example, the dots on these maps are the locations of burglaries, and the ellipses that you see on the top are just standard deviational models. So that's how close to the mean center of those locations are these events happening. And when you can map the ways that those mean locations are relative to each other, you can kind of see some directionality of events in particular, but also you can see where they're kind of clustered. And this application in particular may be helpful for example, public safety. So GIS can also help us ask better questions about the data that we see. We know that right now we don't have all the math that can help us answer these questions, and I think as predictive analytics becomes more and more important, the math is kind of catching up to how we can measure that, how we can look at that spatially and on a map. So one of the things that is kind of a new and emerging phenomenon in spatial statistics is how can the value of one attribute best predict the value of another attribute, given what we know about its location and other features. So in general, some applications of spatial statistics, again, I think it's a fairly common thing. Where I work at the Polis Center, we're a group of applied researchers in the School of Liberal Arts at IUPUI, and we have three main kind of research areas. The first is geoinformatics, where we do a lot of hazard and disaster planning. We do a lot of flood mapping and tornado damage assessments, things like that for FEMA. We also look at measuring neighborhood change and the impact of various policies on neighborhoods themselves. So recently we did a report analyzing the impact of neighborhood features on domestic violence in Marion County. We also look at, in the health arena, how different public health programs and interventions may affect the population of the community and where hotspots may exist in those populations. So more generally, I think these are some examples of where you can see spatial statistics really being used and applied in the real world. Again, in predicting disasters and their impacts, I think as climate change is a more rapidly occurring and more rapidly developing phenomenon, we really need to be aware of how things like the features of the landscape might influence a landslide or might influence the way that fires start in California or the way that flood's going to impact coastal cities. We can also use it to look at the spread of diseases. For example, if we can map the individual incidences of a specific disease, we may be able to determine where it originated. In ecology, you can use it for animal migration patterns and invasive species predictions to see where invasive species may be spreading. Again, the crime area, a lot of police departments are using this data to determine where hotspots are in terms of crimes. And urban planners do use it for neighborhood characteristics to look at where neighborhood boundaries should be drawn and what characteristics of those neighborhoods exist. So thank you guys for having us. I hope that you find something of interest in all of this.